talking about tangent lines in this lesson. Super important, and it's really just related to right triangles, and we're going to see why in a second. So we're going to look at these things called tangent lines. First, what a tangent line is a line that hits the circle at just one point. So if I move this line around the circle, I see it's just touching the circle at one point. And what else do I notice? It always makes a 90-degree angle with the radius of the circle. So a tangent line touches the circle in one point, and it makes a 90-degree angle with the radius. It's perpendicular to the radius. So that's the property we're going to use. It comes up a lot. Here's how it looks. So tangent line is a line tangent to a circle if it touches exactly one point on the circle, just one point, and then the line goes outside. And the tangent line is always perpendicular or makes a 90-degree angle with the radius. So this is the radius, right? Center to the edge of the circle. It's always 90 degrees to the tangent line. So if I made another tangent line over here, not the best drawing ever, but I did all right, it would be a 90-degree angle with that radius as well. So tangent line touches one point, 90 degrees to the radius, and then we just use properties of triangles and right angles to figure out missing angles and sides. So here's one we did in class. We talked about this one. We got two tangent lines, and then we want to know, what do we know about y and z? Well, first, this is a radius, and this is a tangent line. So this angle is 90 degrees. Up here, we got another radius and a tangent line. That was not the best line. I'm going to fix it. That's better. That one's also 90 degrees, right? That's what we know about radius and tangent lines. They make 90-degree angles. So a quadrilateral, remember a triangle adds up to 180, but a quadrilateral, 1, 2, 3, 4 angles add up to 360. All four of those angles got to add up to 360. But we already know this one's 90, and we know this one's 90. So if I take away 180, right, because 90 plus 90 is 180. So what do I have left? 360 minus 180 is 180. So what I'm left with is W and Z got to add up to 180. W plus Z's got to equal 180 because we know this one's 90, this one's 90. We basically started with 90 plus W plus Z. Those four angles add up to 360. Move the 90s to the other side, subtract 180. So we're left with W plus Z equals 180. So this is an example of how to solve problems with angles looking at tangent lines. We can also find or solve problems with sides using tangent lines. So PD is tangent to this circle. So right away, if this line is tangent, we know this is a 90-degree angle. That's super important because now I see some right triangles. I see this little right triangle, and I see, I'm going to do it a different color so you see it better. I also see the big right triangle. And if I look, I have this side of the right triangle and this side of the right triangle. So to find this bottom of the right triangle, when we have 2 out of 3 sides of a right triangle, we can use the Pythagorean theorem. So I'm going to use the Pythagorean theorem. Honestly, I'm going to copy and paste it just to save myself a little time here. Couple things to remember on the Pythagorean theorem. We got 1.2 squared plus AD squared equals 1.7 squared because 1.7 is the hypotenuse of that green triangle. And that's always got to go by itself. Then I just solved the Pythagorean theorem. 1.2 squared is 1.44. 1.7 squared is 2.89. Subtract 1.44 from both sides. AD equals 1.45. Square root of both sides. So AD is 1.2. Now the last part. AD is the whole thing. It's 1.2. It said determine the radius of the circle. So I didn't want the whole bottom. If I want the radius, I just want from the center to the edge. I want half of it. So I'm just going to divide it by 2 at the end. So 1.2 divided by 2 is 0.6. That is how far it is from the center to the edge of this circle. It's 1.6. So again, just going over problem solving with tangent lines, 0.6. That's how long it is from here to here. And if you look, it makes sense, right? Look at this radius. It is smaller than the 1.2. It's